0 in the first equation, what will you remain with there? X1 cubed, this one is 0, isn't it? This one goes to 0 because y1 is 0. This one is minus. Given that z is equals to 2, is the root of the equation z cubed minus 6z squared plus 21z plus x is equals to 0. Determine the value of x, another rule. So the first thing you do is substitute the value of z. Remember, z is a complex number x plus jy. So where there is z, you put x plus. So z cubed means we have x plus jy cubed. Then minus 6, z squared means we have x plus jy squared. Then plus 21, z is x plus jy. Then plus x is equals to 0. That is the first step. You substitute the value of z. Having done that, you expand using binomial. You expand using the binomial expansion. So the binomial expansion starts with when the power is 3, meaning we have 4 terms, isn't it? Yes. So the first term is 3 combination 0, isn't it? Yes. Then we have x and positive jy. So x is raised to power 0, jy is raised to power 3. That is the first term, isn't it? Yes. Second term is 3 combination 1. Then we have x and jy. X is now raised to power 1, jy is raised to power 1 is increasing, 1 is decreasing, isn't it? Then the next term coefficient there is 3 combination 2, then x and jy. So you have x is raised to power 2, jy is raised to power 1. Then the next term there is 3 combination 3. So when you beat 3 combination 3, it means you beat the last term. You see that? So 3 combination 3, then we have x and jy. So x is now raised to power 3, jy is raised to power 0. You are done. Move on to the next. Minus 6 into raised to power 2. It means we start with 2 combination 0, isn't it? Then we have x and jy. So x is raised to power 0, jy is raised to power 2. The x to power n, isn't it? Then the next we have 2 combination 1. Coefficients of binomial, isn't it? Then x is raised to power 1, jy is raised to power 1, because the sum of the 2 powers must add up to 2, isn't it? 1 is increasing, 1 is decreasing. Then the next is 2 combination 2. So 2 combination 2 means you beat the last term, isn't it? So 2 combination 2 into x and jy. So x is now raised to power 2, jy is raised to power 0. You are done with that? Then it is plus 21 x plus jy, then plus x is equals to 0. Are you seeing that? Are you together? Now, because we are using x here, meaning this other x is different from this x we are dealing with here. So what you do, you make a mistake. So instead of making x to be z to be x plus jy, you can say it is x1 y1, isn't it? So that you don't confuse this x and the x of the binomial. Are you seeing? So we have these other ones, let it be x1 y1 to avoid confusing the unknown and the terms of the complex number. So this x is different from the complex number side, isn't it? This x is unknown. You see that? Instead of x, they would have said k or t for us to avoid mixing up. That is the scenario where they were trying to confuse you, isn't it? Good. So let z to be x1 plus jy1. Just put 1 in all the complex part. 1 like that, so that our x remain that unknown. Okay? Are you together there? Good. Or you would have said z is a plus jb, so that you use a and b. Are you seeing that? To avoid confusion. So the next thing is to simplify. Start opening the first bracket there. 3 combination 0 is 1, isn't it? J raised to power 3 is negative j, isn't it? So we have negative j, x raised to power 0, anything raised to power 0 is 1, isn't it? So here we have negative j, y1 cube, isn't it? Then move 3 combination 1 is 3. J squared is negative, so it changes this to negative, isn't it? Then here we have x1 raised to power 1, y is raised to power 2. Are you see? We are simplifying. Then you move. 3 combination 2 is 3, isn't it? Then x1 is raised to power 2, j is raised to power 1, meaning we have j, isn't it? Then y1 is also raised to power 1. We've simplified that, isn't it? Move to the next. 3 combination 3 is 1. Anything raised to power 0 is 1. So what do you remain with there? You remain with plus x1 cube. You're done with that, isn't it? Move to the next bracket. 2 combination 0 is 2. 2 combination 1 is 2 combination 0 is 1. 2 combination 1 is 2, isn't it? Then 2 combination 2 is 1. Anything raised to power 0 is 1, meaning this is 1, and this other one is also 1. So what do you remain with? J squared is negative 1, isn't it? So j squared is negative 1, so it means if you remove j there, you have negative outside, isn't it? Are you together? So what do we have? Now start. Negative 6 times negative 1. So that is positive 6 y1 squared, isn't it? Are we together? Then move on. Negative 6 times positive 2. Negative 12. Then x1 is raised to power 1. Then we have j. Then we have y. We have simplified that, isn't it? Negative 6 times positive 1. Negative 6. Then x1 is raised to power 2. We've dealt with all that bracket, isn't it? Move to the next. Positive 21 times x1 is plus 21x1. Positive 21 times positive jy, you get plus 21j y1, isn't it? Then plus our x will be equals to 0. Having found that, we now separate the real terms with the imaginary terms to form two simultaneous equations. Are we together? You separate the real terms with the imaginary terms. So start. Any term without j is real, isn't it? So it means negative 3 x1 y1 squared is real, then plus x1 cube. So we can start with that x1 cube, isn't it? X1 cube then plus 6 y1 squared, yes. The next one without j is minus x1 squared. The next one without j is positive 21 x1. The next one without j is plus x is equals to 0. Remember, this 0 is the same as 0 plus 0 j, isn't it? Yeah, so both the real and imaginary part will be equated to 0, isn't it? Go to imaginary. Terms with j minus y1 cube. So terms with j, meaning j will cancel out on both sides of the equation because the other side of the equation is 0. Are you seeing that? So minus y1 cube. Move to the next one with j plus 3x1 squared y1. J will cancel out on both sides of the equation. Are we together? Then minus 12x1 y1. J will cancel out on both sides of the equation. Then plus y1 is equals to 0. It was supposed to be 0 j. So j cancels from both sides of the equation. Now you form two equations. Now from these two equations, you now go to the root which you are given. You are given z is equals to 2. And remember you said that z is x1 plus jy1, which is equals to 2. So when it is equals to 2, it means it is 2 plus 0 j. That's why j is not there. Are you seeing? Are we together? So from there you can now see x1 is 2 and y1 is what? 0. So where there is x1, you put 2, and where there is y1, you put 0. Then you would have found the value of x, unknown. You use this known root to get the value of unknown. Are we together? So where you see x1, you put 2. Where you see y1, you put 0. And that one you can do in the first equation because it is the first equation which has the unknown. Are you seeing that? Yes. Are you clear there? So x1 cube, 2 cube, you get 8, isn't it? This one goes to 0 because y1 is 0. This one goes to 0 because y1 is 0. Then minus minus 6 x1 squared, meaning 4 senior. Then plus 21 into x1, isn't it? Because x1 is 2, isn't it? Then plus x is equals to 0. Can you now simplify this? 8 minus 6 times 4 is 20. 24. 21 times 2 is 42. So can you work that out? 8 minus 24 plus 42, what do you have? 8 minus 24 plus 43 is 26. So 26 plus x is 0. So this implies that x is negative 26. So you've answered the first part of the equation. You determine the value of x. Are you seeing that? Yes. So the value of x is negative 26. Negative 26. So where there is x, you put negative 26, meaning that is negative 26. So having determined the value of x, we now determine the other rules. So for you to determine the other rules, you must not have a known in the two equation, meaning the unknown will be substituted with this value, isn't it? So we now have two equations, equation 1 and equation. So the equation which is usually easier to solve is the equation arising from the complex number. Because from the complex number, you see there's a common factor to be factorized out. Are you seeing? Yes. Are you clear there? So in this equation, if you factorize out y1, here you remain with the negative y1 squared plus 3x1 squared minus 12x1 plus 21 is equals to 0. So this means either y1 is 0 or this is 0, isn't it? So it means y1 is equals to 0 or negative y1 squared plus 3x1 squared minus 12x1 plus 21 is equals to 0. So this is rising from equation 2, meaning what you found here, you found it in equation 2. So you use it, you substitute it in equation 1. Are you seeing how to solve it? Yes. You substitute equation 2 in equation 1. So when you substitute this second part, or this first part, you get the same solution. Are you seeing that? Yes. So you use the one which is simpler to use. The one which is simpler to use is when y1 is equals to 0. You substitute in the first equation because you've gotten it in the second equation. Are you seeing that? Are you together? So you go to the first equation where you see y1, you put 0. Are you together? So if you put 0 in the first equation, what will you remain with there? x1 cubed, this one is 0, isn't it? This one goes to 0 because y1 is 0. This one is minus 6x1 squared plus 21x1 minus is equals to 0. So you use this to determine other rules. So first of all, you check with the factor theorem. You check with the factor theorem if there are roots which are integers. If such rule does not exist, is when you now go the way of dealing with a cubic equation. Help me with the calculator. ES. Now we want to test. Where there is x1, you put answer. So we have answer cubed minus 6 answer squared plus 21 answer minus 26. So you start testing when x is 1, what is the answer? Negative x. It's not the root. It is only the root when you get the answer to be 0, isn't it? You test 2. When 2 is equals to 2, I get 0, meaning 2 is a root. In fact, 2 you were given. You see? Yes. So 2 is a root. So we found x1 is equals to 2 is a root. So what do? You bring 2 this side, it means x1 minus 2 is a factor. Are you seeing the process? Yes. That is one factor. So once you get this factor, you use the polynomial division to remove it, to get the other factors, even if you don't go on with the testing. Are you together? Yes. You use polynomial division. So from here we now have we want to divide x1 cubed minus 6 x1 squared plus 21x1 minus 26. We want to divide with the first root, which is x1 minus 2. Are you see that? Yes. We use polynomial division to determine another root. So from there, x1 minus 2, how do you get x1 cubed? You multiply by x1 squared. So if you multiply this by x1 squared, you get x1 cubed by minus 2x1 isn't it? If you subtract 0 minus 6 minus 2, that is minus 6 minus negative 2, you get minus 4, isn't it?
Yes.
You get negative 4 x1 squared plus 21 x1 minus 26. Remember, you are not going to get a remainder because x1 minus 2 is a root, meaning you cannot get a remainder, you end up with 0. Are you seeing that? So from there, how do you get negative 4 x squared from x? You multiply by negative 2 x1, isn't it? Negative 4, I mean. Negative 4 x1, isn't it? Negative 4 x1 times x1 is negative 4 x1. Negative 4 x1 times negative 2 is positive 8. x1, isn't it? So if you subtract this minus this is 0, 21 x1 minus 8 x1, you remain with 13. x1 minus 26. So how do you get 13 x1 from x1? So you multiply by 13. So it is plus 13. So 13 times x1, you get 13x. 13 times negative 2, you get minus. So you must get 0 because this was a root. Are you seeing that? So it means after factorization, what have we ended up with? X1 squared minus 4 plus 13. So this is now quadratic. We now use the quadratic formula because those roots may not be integers, isn't it? When it reaches quadratic, you now use quadratic formula. Now we have x1 squared minus 4x1 plus 13. We want this one to get the other roots from this using quadratic formula, isn't it? Because it is this, if you multiply with that first root, which was x1 minus 2, you are supposed to get 0 because this times this is giving you the problem we had, isn't it? So either this is 0 or this is 0. So we are now dealing with the second part, or this is 0, isn't it? Quadratic formula, what is your A? Your A is the coefficient of x1 squared, isn't it? Your B is negative, and your C is positive. So x1 is supposed to be minus B plus or minus square root of minus 4 is C over A. So start. Minus B minus negative 4 is 4 plus or minus square root of B squared. Negative 4 squared is 16. Negative squared is positive 4 squared is 16, isn't it? Then minus 4 times A times C. 4 times 13 times 1, 52. 16 minus 52, isn't it? Over 2A, meaning over 2, isn't it? So we have 4 plus or minus, what is 16 minus 52? Negative? Negative 36. So remember, square root of negative 36 is the same as square root of negative 1 and square root of 36, isn't it? So square root of negative 1 is j. So it means when negative goes outside, that is j. Are you see? Then the denominator we have over 2. So what is square root of 36? 6. So if you divide that by 2, what do you get? 4 divided by 2 is 2 plus or minus 3j. So what are the other roots? The first root there you can see x1 is 2 plus 3j, and the other root x1 is 2 minus 3j. Those are x1. Are you together? So you found the other roots to be this. You found the other values of x1. First value of x1 you found was equal to 2, isn't it? The second value of x1 here you found is 2 plus 3j. The third value of x1 here you found is 2 minus, and you found all these values when y1 is equal to what? 0. So we now want to get the roots of the complex number. The roots of the complex number z is x1 plus y1j, but y1 is equal to 0. So where this y1 is 0, it simply implies that z is equal to x1. So it means the values of x1 are the values of z, because y1 is 0. Are you seeing that? So you can now see z is equal to x1, meaning z is equal to 2. Then you can now see z is x1, meaning z is 2 plus 3j. Z is equal to x1, meaning z is 2 minus 3j. So these are the roots of that equation. And one of them you were given z is equal to 2, which is this. So you found the other roots. And that is how to solve that problem. You see the way it's simple. Good. We'll deal with that kind of problems in the next lesson.